Gas regulators are fascinating devices and necessary tools in many chromatography applications. What they do is very simple. They reduce the high pressure of a gas source to a low, safe, and consistent working pressure. But with many options available, choosing the right one can be a difficult task. In this Restek tip, we're going to share what you need to know about gas regulators. What are the differences between them, and what should you consider when selecting one? Let's begin with cylinder connections. The type of connection or fitting that you need generally depends on the type of gas and the amount of pressure. In the U.S., the Compressed Gas Association has dozens of fittings that are part of their CGA standard. A CGA 580 fitting is used for helium, nitrogen, and argon, while a CGA 350 fitting is used for hydrogen. Other organizations also have their own fitting standards, which are used by different countries. Check what fitting type your gas cylinder has before trying to select the type of regulator that you need. Another factor to consider is whether you need a single-stage or dual-stage regulator. Single-stage regulators do just that. They reduce the pressure in one single stage. They are most useful for applications where the output pressure can vary slightly without causing problems, or the input pressure from the gas source is less than 500 psig. Dual-stage regulators are better suited for applications where your outlet pressure needs to be very consistent, such as connecting to a GC. Next, you should consider the pressure of your gas source and the delivery pressure needed for your application. Regulators are designed to handle specific ranges of both incoming gas pressures and exiting gas pressures. Start with the inlet pressure. Look at both the minimum and maximum pressure ratings and requirements. Then consider the output pressure for your instrument or inlet. While the range on the gauge may vary, note that the actual working range will be lower. A 0 to 200 psig gauge has a working range of 0 to 150 psig. Finally, factor in the regulator's construction material. Chrome-plated brass is usually chosen because of its lower cost, while stainless steel is more resistant to corrosive gases. Both materials are good for higher purity analyses. If your application requires more inertness, you should look for a regulator that has a treated surface, such as sulfur-inert. Now, what about the diaphragm material? While some regulators have neoprene or other soft diaphragms, for chromatographic applications, we recommend stainless steel to avoid possible contamination issues. By asking these key questions and keeping these tips in mind, you'll be ready to go when you need to select a new regulator.